Hello my friends, welcome back to this implementation of Thompson sampling. So at the end of the previous tutorial I asked you to implement by yourself, step 3, now that step 1 and step 2 are well implemented. And so your exercise in the step 3 was to indeed figure out the trick to select the ad that has the highest random draw among all these random draws taken from the different beta distributions for each of the ads. So I hope that you tried. Congratulations if you succeeded, and even congratulations if you only tried. What matters is that you practice. And no worries, now we're going to implement the solution together. So let's do this. So the first question I have for you is, do we have to stay in this second for loop? Well, yes, of course, because that trick to keep in memory the maximum of the random draws has to be done through all this second for loop, iterating through the ads. And it's only until we get the final random draw that we can know which one is the maximum. So of course we stay inside this for loop, and very simply, since we have this random beta here, which is indeed the random draw from the beta distribution of the ad I we are dealing with right now, what we have to do now is naturally to compare this random draw to max random, the maximum of the random draw, which, okay, so far is initialized to 0, at the beginning of the for loop, but then of course you guess that we will update that value of max random to the new random beta if the new random beta is higher than the maximum, and therefore, over the iterations of this second for loop iterating through the ads, max random will be updated each time we get a random beta that is higher than the previous random betas, meaning that is higher than this max random parameter. So that's exactly the same trick as before, with the UCB algorithm, when we were updating that maximum of the upper confidence bound at each iteration of that second for loop. So here it's exactly the same, and therefore you know what is the next step now. The next step, I'm going to scroll down a bit. The next step now is to start, of course, with an if condition. An if condition which will check if, that random draw, this random beta variable here, is higher than this maximum random draw. And if it is the case, then inside this if condition, we will say that this maximum random draw has to be updated to become the new random beta that was just higher. Okay, and at the same time, we will select the ad of index I inside the same if condition, because anyway, if we get a new higher random beta, this ad will be updated as well. Okay, so I'll show you. Let's first write this if condition. So if random underscore beta is larger than max random, all right, then colon, and inside, what do? We, of course, update the value of max random, the maximum of the random draws, to become that new random beta, which is indeed higher than the maximum random draw collected so far. And then, as we said, if that's the case, if the ad I we're dealing with right now has a random beta that is higher than the max random draw, we can select this ad to become this index I. All right, so let's simulate, the first iterations of this loop. First, max random is equal to 0. Then I begins at 0. So first we're dealing indeed with the first ad of index 0. We compute the random draw from the beta distribution of this first ad of index 0. Then, of course, random beta will be larger than max random. So max random will be updated to become the value of that random draw of the first ad, and we will select that first ad. Then I will be equal to 1, the index 1, meaning the index of the second ad. Then we will take the random draw from the beta distribution of this second ad of index 1. If this random draw is higher than max random, which is equal to the random draw of the previous ad, then we will update max random to become this new random draw of this new ad, and we will select this new ad to become the ad selected. And otherwise, if this new random draw from this new ad is not larger than max random, then we will do nothing and we will just keep the previous ad and the previous max random. And we repeat this, through the iterations of this second for loop up to the last ad, the ad of index 9, and successively, max random will be updated if needed, if the random draw is larger than the maximum random draw, and we will select the right ad accordingly. Okay, so very easy trick, and you know that's a classic trick in Python to get the maximum of a list through a for loop. So it's really good that you know this trick, and it's really good that you did it twice, you know, once with UCB to compute the maximum of the upper confidence bounds, and with Thompson sampling to compute the maximum of the random draws. So now you're all set with getting maximum techniques, and therefore, time to move on to the next step now. By the way, congratulations if you got this right. I know it's not that easy the first time, but you know, by just repeating this over time, you will become so good at this. And now, what, according to you, will be the next step here? Well, I imagine some of you are wondering if we need to do an else here. And the answer to that is no. We don't need to do an else, because if this condition is not true, well, we'll just keep the last add that had this maximum random draw. So no need to do an else here. And in fact, well, the second for loop is done, because it gives us exactly what we want. It gives us the add that has the maximum random draw among all the adds from 0 to 9. And therefore, that's why I got out of this second for loop and I got back into this first for loop, you know, right here. I'm at this level now, right? Okay, so there we go. Now we just need to finish this implementation, because basically, you know, step 1, step 2, and step 3 are done. I know it's a little bit easier than the UCB algorithm, but you're going to see that in the end, the result might be even better. I won't tell you exactly if it's going to be the case, but you're going to see. We're going to have a good surprise for the end. Okay, so now let's finish this implementation. Basically, we just need to, you know, update the different variables we have here. You know, we need to update exactly these 4 variables: add selected, numbers of rewards 1, numbers of rewards 0, and total reward. So I suggest we start by updating add selected. So I'm going to copy this actually. This will be simpler. And then right here, you know, make sure to be at the right level, you know, at the level of this first for loop, you know, for n in range 0 to n. And now I'm going to paste that add selected variable. And so now over to you. According to you, what do we need to do here? How do we need to update that add selected variable? Well, exactly the same as in UCB, of course, since this variable corresponds to the full list of the adds that are selected over time. You know, it contains all the adds that are selected over time up to the 10,000th round. And well, each time we select a new add, we need, of course, to append this new add that was just selected, which has index add, of course, into this add selected list. And therefore, in the append function, we of course need to input add. All right, perfect. So that appends the add to this full list of the add selected, which will be, remember, the input of the histogram. Then, as we said, we need to update these 2 variables, numbers of rewards 1 and numbers of rewards 0. But let's think this through. How do we need to update these 2 variables? Well, that actually depends on something specific. It is whether when, you know, we selected that add at this particular round for a particular customer, it depends on whether the add that was selected got a reward 1 or a reward 0. Because indeed, if it got a reward 1, well, this needs to be incremented by 1. And if it got a reward 0, well, this needs to be incremented by 0. Right? We can actually see that clearly in step 1. ni1n is the number of times the add I got reward 1 up to round n. So if at a new round we get a reward 1, well, this has to be incremented by 1. And same with this one, this is the number of times the add I got reward 0 up to round n. So if at our round end we got a reward 0, well, this needs to be incremented by 1. And therefore, what we need to do here, since we have, you know, 2 different conditions, well, we need to do, of course, naturally, an if condition, once again. But a simple one, it is an if condition that will just check if, well, the reward is equal to 1. So far I'm just going to write this, reward, and then be careful, double equal 1, instead of just 1 equal, because otherwise this would be an affectation, then colon. But now you're going to say, wait, we don't have any reward variable. Well, that's because same as in the UCB implementation, I just want to highlight what is this reward. Remember, and therefore just above, I'm going to specifically say what is this reward, and that, you know, that's exactly the same as in the UCB implementation. It is the value in the dataset corresponding to the row we're dealing with right now in this first for loop, you know, with this particular customer, and the column of the ad that was just selected, right? Because the reward is the value we get after selecting this ad here to show to the specific user we are dealing with right now in this first for loop. And therefore, the reward here is the value in our data set, right? So I'm taking my data set and then the values attribute, and then in square brackets, I enter the row of the user we're dealing with right now, which is n, so n, and then the column of the ad that was just selected, which is ad, right? That's exactly the same as in the UCB, but I clearly wanted to highlight what is the reward here, so that then we can check in an if condition if the reward is equal to 1, and if that's the case, well, what are we going to do? Well, as we said, we're going to increment this by 1, because if the reward is 1, that means that the number of times this particular ad got reward 1 just got incremented by 1. Then of course I'm taking the right index of this list of the different numbers of times each ad got reward 1, but the ad we're dealing with right now has of course the index ad, because that's the ad that was just selected, and therefore I just need to copy this and then add equal, paste that again, and then add plus 1. All right, so all good. This particular value is updated the right way. And now back in the else condition, meaning the other condition where the reward we got by selecting this ad at this particular round is equal to 0, which can be specified through an else because reward can neither be equal to 1 or 0. So else is fine here. And then, well, what we need to do is, of course, take that, I can just copy all this and paste that and replace, of course, numbers of rewards 1 by 0 here, and same 1 by 0 here as well. Because in this else condition, we're in the condition that the reward we collected is 0, and therefore that variable of the index ad here, which represents the number of times this ad here got reward 0, needs to be incremented by 1. All right, perfect. And now we just have one final thing to do. You know exactly what it is. Let's not forget about this. It is to update that particular variable which gives the total reward, the total accumulated reward over the round. And since now we are, in a new round, with this first for loop here, well, of course, as soon as we get this new reward, we need to update this total reward by incrementing it by the reward we just got, whether it is 0, in which case there is no incrementation, or 1, in which case we increment it by 1. So let's do this efficiently. Total reward is equal to total reward plus reward. All right, and that way we update our total reward variable. And that's it, my friends. Now the implementation of Thompson sampling is over. So congratulations, you just implemented your second reinforcement learning model. And by the way, now the full implementation is done, because indeed, here we don't have anything to change. We can just plot the histogram because we have the same variable names. So now it's time for the showtime. In the next tutorial, I will show you the demo of, Thompson sampling. We will, of course, run all our cells, and mostly we will compare the two performances between UCB and Thompson sampling. I remind that UCB was perfectly able to find that best ad, with the highest click-through rate in 1000 rounds, but was not able to do it in 500 rounds. And so now I'm super excited to check if Thompson sampling will do better than this, meaning if it will not only be able to figure out that best ad in 1000 rounds, but also if it will be able to find it in 500 rounds, which UCB couldn't do. All right, so let's find out about this in the next tutorial. I can't wait to show you all this, and until then, enjoy machine learning.